Good afternoon. It's 12 o'clock on Wednesday, at least 12 Central Daylight Time. And that means it's time for another conservation webinar, Iowa Learning Farms conservation webinar. I didn't moderate last week, and now I'm all tongue-tied here. So I'm Matt Helmers with Iowa State University and the director of the Iowa Nutrient Research Center and a faculty affiliate with the Iowa Learning Farms. And excited to be back hosting the webinar, and really feel fortunate to be able to hear this presentation and introduce a scientist from Agriculture and Agri-Food Canada, Dr. Craig Drury. Like to call him a friend as well. We've gotten to know each other as part of a regional project, a Nutrinet project. And before that time, I had not interacted with Craig, but have really come to appreciate him as a scientist, and I think does great work. And I always love his virtual background on his slide. It always makes me think of all the work he does and the extensive work that he does to look at volatilization in our crop fields. So with that, I'll turn it over to Craig to talk about maximizing N availability to crops while minimizing N losses to air. As always, if you have questions, please type those into the chat box and we'll get those to Dr. Drury at the end of his talk. With that, the virtual floor is all yours, Craig.
Thanks a lot, Matt. I really appreciate this opportunity. And yes, it has been a fun few years working together. So in this particular talk, this was sort of the title that I submitted, but thinking about it a little bit more, thinking maybe I could have also used the title, How to Make Your Nitrogen Work Harder for You. So there's been a lot of people that have contributed to this work over the years. I'd like to acknowledge my cooperators at the Ag Canada Centre in Harrow, Dan Reynolds, Shiming Yang, Lori Phillips, and Mike Gomo. So the objectives of my research and this talk really are to develop nutrient management strategies which reduce fertilizer nitrogen losses to nitrous oxide, ammonia volatilization, nitrate leaching, and enhanced crop yields. I'm not going to spend too much time on nitrate leaching today, just to keep it within the 25 minutes. So I'm going to focus more on the air losses. Now, Canada is coming up with various objectives over the next few years. And one of the challenges we have is to try to reduce nitrous oxide emissions from fertilizer by 30% by 2030. And I'll be discussing this and showing you some results where this is, in fact, an achievable goal if you consider sort of the 4R nutrient management principles. Ultimately, we'd like to also achieve net zero emissions by 2050, and this will be not only managing N and greenhouse gases, but also through enhanced carbon sequestration in soils as well. Now, every nitrogen researcher has a slide like this showing, the N cycle in this case. And probably most of you and myself at times, our eyes sort of glaze over at such figures. So I'm actually have another way of describing it, which I'll show you in a minute or two, but maybe just sort of focusing on the red circles here. So everywhere where there's a red circle, it represents a type of loss that can occur. So if we add urea fertilizer or a UAN, especially if it's added at the surface, we can have considerable amount of ammonium loss. We can also have nitrification processes that convert the ammonium through to nitrate, and we have N2O losses, surface loss of nitrate, tile drainage loss of nitrate, leaching loss. And what we want to really do is we want to focus on reducing as many of these losses as possible, and to have more of the nitrogen go in this green zone, the green circled area, where it goes into the crops itself, whether it's food crops, fiber crops, or biofuel crops. Come up with a better way of maybe a conceptual way of describing the losses a little bit better. So in this particular starting slide, if you can imagine the soil as a pipe and valves are where we have pipes where losses can occur. So we may start by adding, as an example, urea to the soil. And that's the very first reaction that occurs is conversion of urea to ammonium. And unfortunately, some of the ammonia gas can go right up into the air. So we're in fact fertilizing the air and not the soil. After urea is converted to ammonium, and given that some losses occur, then it goes through the next process, nitrification. And when we do get heavy rains, especially after fertilization, then we have denitrification going on, which is a microbial process that occurs in pretty well all soils when it becomes anaerobic and there's nitrate there. And we lose a lot of nitrous oxide, dinitrogen, NO, and of course, N2O is one we want to target, in particular because it's a greenhouse gas that affects the ozone layer. If we have a lot of rain as well, nitrate leaching into the groundwater or through tiles can occur. And really, the plant at the very end is really only has the amount of nitrogen left after all those losses occur. So we want to try to control this. So this top center is what I started with. I'm going to go through a couple of different scenarios. So really, let's talk about these valves as really a management practice. So it's really to sort of turning off some losses. So the first practice I want to describe is the addition of a nitrification inhibitor that slow down the conversion of ammonium to nitrate. And that may, in fact, very effectively reduce N2O emissions. However, N2O, from an agronomic standpoint, I mean, it typically, I've measured, 5-10 kilograms of N out of 160 lost. We won't necessarily see a large change in the crop growth. And in fact, in some cases, we have even more ammonia when we keep the soil at the NH4 plus ion stage. So another way of going about it is, okay, well, let's use a urease inhibitor or let's incorporate the soil. Both of those techniques, again, another valve on this sort of this pipe, and we can really ratchet down, maybe not eliminate, ratchet down the ammonium loss. So our ammonium losses, certainly from the beginning, go down. I'll show you some slides to demonstrate that. Two things that happen. Because ammonium loss can be so great, yes, this plant's supposed to look a little bit taller, so yields can go up. But if we have more nitrogen in the soil and it rains, we can have higher N2O emissions compared to the starting point. So it's a pollution swapping scenario. We've decreased one loss, and like a pipe with a lot of holes, it'll come out another hole, or even more nitrate leaching. So what we really want to do is try to look at a combination of practices, and there's many practices that we could put together that can achieve this, that not only decreases ammonium loss, but also some of the other gases. So in this example, it could be injecting UAN instead of broadcasting urea. It could be adding inhibitors. It could be conservation tillage, cover crops, so forth. But by stacking practices, in a lot of the ways where you stack chemicals with herbicides, we can achieve this greater reduction of losses, and we have a taller growing, higher yielding crop. So let's go back to sort of the basics of nutrient stewardship practices and how they can increase nutrient use efficiency. So of course, we've heard that, yes, we can look at different sources, whether it's urea or UAN, whether it's adding a urease and nitrification inhibitor with them. When do we apply the nitrogen? Again, if we apply it closer to when the crop needs it, if it's corn, maybe a side dress application instead of all at planting. Where do we place the nitrogen in the soil? Can we in fact target the root zone and reduce the amount of surface losses? And if we get these three things right, then we might be able to ratchet down the rate. Because if we've reduced losses and we haven't adjusted the rate, then the crop has more nitrogen than it needs, and that's when the high risk of losses are very problematic. And lastly, we can't really forget this whole conservation piece as well. How do we enhance soil health and soil carbon? Well, cover crops, crop rotation, conservation tillage. By improving the soil, it has better water holding capacity, it doesn't get as wet, so it's not as subjective to losses. That again is another tool that could be used for multiple benefits, including reducing losses to the environment and getting more of your nitrogen into the crop. So I'm going to take you through sort of 3 or 4 different studies and give you examples of the comparisons of what I've done and how this has impacted the results. Now, as you know, there's a lot of options here. We can look at different ways of different sources, whether it's urea or UAN. There are others as well in hydroammonium, different inhibitors, a single inhibitor, a dual inhibitor, different placements. Like there's so many combinations and you can't do all these at once. So I started out fairly slow and looked at a very simple sort of comparison, whether it was broadcast on the surface or injected in the soil, whether it was just urea, which is broadcast, or UAN, liquid injected, which is urea ammonium nitrate, and with and without a combined urease inhibitor. In this case, it's Super U, or for UAN, it's Agrotane Plus. So here, let's look at the broadcast urea. In this 2014, we were applying 130 kilograms of N, and 40 kilograms of that 130 was lost if it was just broadcast on the surface. Same nitrogen rate, but just adding Super U, so it's a with the urease and nitrification inhibitor, decreased losses from 40 down to 10. Once again, injecting same N, no inhibitors, that's the red triangles, our losses are only 10 kilograms, and we can actually eliminate the losses by adding the Agrotane Plus, the dual inhibitor, as well as the UAN. So again, we've gone from 40 kilograms down to 0 loss. So that's 40 kilograms more in the soil available for the plant. I'll give you some other examples, but in this particular study, this 2-year study, the broadcast treatments averaged about 172 bushels per acre. We had an 8 bushel or 5% increase when we added the inhibitors with the broadcast urea, so with whether urease or a urease and education inhibitor. But going to injection was a 17 bushel increase or 10%. But when we stack processes, and again, this is all the same amount of nitrogen, we stacked it and added inhibitors, we've gone from 172 to about 205 bushels per acre. So it's, about a 31 bushel increase, which is fairly dramatic and certainly worth doing. Okay, now I want to talk about timing and end sources. So I usually try to look at 2 different factors in any one study. So this is the next sort of 3-year period. So we have control without any added N, nitrous oxide emissions are low as expected, higher with the pre-plant. So it's added just actually the day of planting, or we add the nitrogen and then sort of plant right after that. And we have just a little bit less than 2 kilograms loss. If we add the urease inhibitor, that actually is like that pollution swapping scenario I was showing you, slightly higher emissions. But when you add the combination of urease and nitrification inhibitor, we had about a 28% reduction, which is close to that 30% that we're trying to achieve. But if you just take that pre-plant N and add the same amount, but as a side dress application, we've avoided the first 4 weeks where if it got really wet, we'd have a lot of losses. So we've avoided those losses, reduced the N2O emissions. Even with the urease inhibitor, it was at 2.3 and now it's down to about 1.7. It's reduced. And again, the combination of delaying with the side dress and the dual inhibitors, we have 34% lower losses. And our yields, just by delaying the N, we've avoided losses. And in terms of all of our treatments that are side dress, had a 14% greater yield. So it made it worthwhile. Okay, moving on, we also compared in a different study, okay, what if we wanted to add all the nitrogen all at planting? And here we are able to look at the broadcast urea application, which is the treatment I usually always use as a reference compared to the broadcast with the dual inhibitors. And we can see in this 3-year period, our losses dropped from 22 to less than 10, or by 55%. But we also had a treatment where we, because it was before planting, we were able to broadcast, do some shallow incorporation, maybe in the top inch or so. And just by incorporating a bit, we had a 34% loss, or reduction in loss, and even lower when we broadcast as well as add the dual inhibitor. That's the green bar. But as we've seen before, injecting basically almost eliminates losses, 98% reduction just by injection. But injection with inhibitors, we actually see a net increase because of ammonia deposition, which occurs from the air. So in that particular study, yields, again, our inhibitors were especially effective, not as much effective with pre-plant, going from broadcast incorporation, just without any of the inhibitors, 3 bushel increase, injection of 4 bushel. But when we combine it with these inhibitors, we are getting anywhere up to about 9 to 13 bushel increase comparing to just broadcasting alone. So this is a study that I was involved in with Matt and many of the other colleagues down in the US. And here we're comparing broadcast urea with a single slot injection, which is what most farmers are using who are applying, injecting the nitrogen in the soil. Again, these are all side dress applications when the crop is, 5 to 6 leaf stage. So here we're adding the same amount of nitrogen in all 3 treatments, but a double slot just means that we have half as much nitrogen in each of the slots. And the reason why we are doing this is that as urea hydrolyzes, the pH goes up. If we have it all in one zone, the pH will go up higher because there's more hydrolyzing. By splitting in 2 zones, in each zone, the pH won't go up as high, so theoretically should reduce the losses. Now, I'm going to spend time more with the cumulative losses, but just show you how we measure it. We deploy 24 wind tunnels in different reps, have all these treatments applied. This is all done the day of application. Every day we have these wind tunnels to measure ammonium loss, take samples at the beginning of them, air samples at the end, look at the difference, change the traps every day, and we measure ammonium loss throughout the entire growing season. This is the top one are broadcast treatments. The bottom are single injection treatments. All the injection, the red triangle single injection, which had the highest loss, and especially, and the losses occur not just the day of application, the first 2 or 3 days. We had actually losses occur up to really 3 weeks after application before they went down to that 0 level. So when we look at the cumulative losses, we could see, let's focus in on this single injection UAN. We have, in this particular year, 2019, we had about 17 kilograms in loss. And you might wonder, well, if it's injected, how is it lost to the air? Well, and I've got in the upper right graph a drone image that we took that shows that sometimes, even with packing wheels, if we have very dry conditions after injection, that slot can reopen a bit, not every year, but especially if we have a week or 2 dry conditions after application. It's a shrinking, swelling clay loam soil. It opens up a bit and we can still have some losses. But the good news is going from single slot to that double slot, pH won't go as high. We've reduced the losses. If we look at single slot without inhibitor compared to the triangle of dark red with inhibitor, we've also reduced loss. And even the double slot with no inhibitor compared to with inhibitor, losses dropped even further. So over a 2-year period, 13 kilograms lost, dramatic decrease with the inhibitors. So adding Super U with the dual inhibitors with broadcast urea. Single slot at a 23% lower reduction, just going from broadcast to some incorporation, but almost eliminated with the single slot and the dual inhibitors. But going from single slot to double slot without inhibitors, we're able to reduce it by 65% and also lower it with the dual inhibitors. And so yes, in fact, those dual inhibitors can bring us down anywhere between 72 to 97%. We also measure nitrous oxide emissions just to show you that we do take them many times through the growing season, through June through to November. If we have precipitation at the top, here's like a 3.5-inch rain. We have a spike afterwards. Here's 70, so that's almost a 3-inch rain. We have spikes because it occurs under wet conditions. And we can also see treatment differences here, the top ones being broadcast, the bottom being injection. And we can see that really all the losses occur after the side dress and application because there's nitrate in the soil to be lost. And instead of going through each line, I'll show you the summary slide associated with this. There's a cumulative one where we can see here's a double slot and single slot had in this particular area same losses. But when we had the corresponding treatments with the inhibitors, we're able to reduce N2O loss. Here's even with just the urease inhibitor alone, that whole pollution swapping, our N2O goes up. But if we had broadcast urea with the dual inhibitor, which is a dark blue, it has lower losses than just broadcast urea alone. But if no N is applied, of course, crop doesn't do well, but we have low losses. That's the control in the bottom. So looking over a 3-year average, 2019, 2021, we have on average single slot injection at our highest N2O losses, a little over 7 kilograms N per hectare, 16% reduction when the inhibitors were applied, 16% reduction with double slot, and 53% reduction with the double slot and dual inhibitors. And you sort of think, well, if you compare that to broadcast is a lot lower. Reason why it's a lot lower is there's not as much nitrogen left in the soil because it was all lost to ammonia. So again, we have to consider multiple losses occurring. And once again, with this double slot compared to single slot or the broadcast, our yields were 7 to 13% greater than the broadcast urea. So it clearly was sort of beneficial. My last sort of set of slides is going to talk about what we're currently working on. This is actually year 3. Next year we'll be doing our side dress application. So it's a little bit preliminary. I'd sooner have all 3 years worth, but I thought the results were interesting enough to show you what we're working on. So we're comparing with no cover crop. This is cereal rye that's killed in the spring versus planted into rye versus no rye. We also went with and without inhibitors in this particular study. And here, if we look at cumulative volatilization, last year in particular, we had sort of a drought period after application. I remember even seeing in the field 10 days after application, we had some urea prills on the broadcast treatment that hadn't dissolved, which is quite amazing. So we had very, very high losses. We were adding 160 kilograms, about a third of it was lost to the air. We were able to reduce that about 47%, almost half, going from the broadcast with Super U, the dual inhibitors. This first 2 are with no cover crop, and then injecting it, by injecting both with no inhibitors, with the dual inhibitors, 88 to 97% a reduction. These last 4 bars represent when we had cover crop present. So even with the cover crop present, that alone reduced losses by 46%. And we also saw a benefit with the cover broadcast urea with the dual inhibitors and the cover crop. injection, negligible losses, in fact, net deposition. N2O emissions, here we also see low with the broadcast urea because of that, most of that N, 50 kilograms lost to ammonium, so there wasn't a lot left later in the season for N2O emissions. We saw a 34% reduction with the injected no cover crop inhibitors, and we saw, going with the injected UAN, a 20% reduction in emissions with cover crop and the inhibitors of 44%. So very effective way, and also the benefits of adding a cover crop to the system. And this is sort of the last data slide, this next pair. So here we look at yields. So as we've seen before, broadcasting compared to broadcasting with inhibitors, we had a 9 bushel increase, 6%. Going from broadcast to injection, 28 bushel increase, 19% yield, and a 25% yield bonus when injecting with the inhibitors. Now, I'm splitting this graph up for a purpose. What we see, however, is a huge yield hit when we broadcast urea with the cover crop. So what's happening is the cover crop, when we applied it, it was side dress, it was starting to decompose, and all that nitrogen that we put went to the microbes to decompose the cover crop. So you can, in fact, depending upon how you manage nitrogen, have these high yield penalties at times cover crops, but you can overcome these by putting the nitrogen lower into the soil, probably about 3 inches, and there we're seeing these yield benefits with injecting and with the cover crop, where we can see up to 18% or 27 bushel benefit of injecting the cover crop compared to broadcast urea. So lastly, if we look at the N rate component, I haven't talked to that. If we have a normal yield response curve, our yield goes up as the fertilizer rate goes up. We have an optimal amount, and that's the most economic rate. If we have one of these nutrient management practices, we can reduce losses so that rate occurs at a lower fertilizer amount. And so that most economic fertilizer rate is actually reduced with some of these nutrient management BMPs. And so this represents a savings of fertilizer dollar. So really the grower's profits can increase as long as the cost of this new management practice or product is less than the value of fertilizer saved. Or this example shows no crop yield increase. We've shown that you can also have a crop yield increase. So that again has to be taken into consideration and may make it even more worthwhile to adopt some of these practices. So sort of as a summary, you've got to look at nutrient management from both perspectives. How do you use 4R, injecting UAN, putting these valves in the pipes, and conservation ag to improve soil properties to ultimately optimize your crop yields. Take-home messages: side dress and application avoids early season N2O emissions because you've missed that time period that could be lost. I really promote, if you're going to use inhibitors, try to use a combined urease and nitrification inhibitor. Look at improved placement, as we talked about, not only placed in the soil, but if you can, modify and have a dual injection, and these conservation ag practices to improve soil carbon from these cover crops or diverse crop rotations and conservation tillage. So your crop can better withstand adverse weather conditions such as droughts and excess rain, which I realize you're having, and we've only had about an inch of rain since the beginning of May here, so we're in a drought situation as well. We've had a lot of funding, in particular some farmer group, Grain Farmers, Fertilizer Canada. This is a project I was involved with MAP, Foundation Food and Agriculture Research, and for our research fund, and to all the technical people who helped with this project. I'll end on that, and then I'll pass this over to Matt to do the next couple of slides.
All right. Thanks, Craig. very interesting and important work. And so if you watched this webinar live and you want a CCA CEU, please send your name, the name you entered to watch the webinar, and your CCA number to Elena Whitaker, ALENAW, at iastate.edu by 5 o'clock today. Again, ALENAW at iastate.edu. Okay, as we move to the next slide, I'll put a plug in that if you have questions, please type those in the chat box and we'll get those to Craig at the end of his talk. And Craig, if you want to move one slide. Okay, if you watch this webinar live, if you're willing to fill out a voluntary survey, it would be great. Only one survey response is needed for all the 2023 webinars. So if you have already filled out this year, thank you very much. And you can find that at learningfarms.org/survey, or you can scan the QR code, and I'll leave that QR code up just another few seconds. And maybe let's go to the next slide. Okay, and so next week, we're going to have Shane Wolf, that's the Wetlands Project Manager for the Iowa Department of Agriculture and Land Stewardship, and he's going to talk about water quality wetlands in Iowa. So tune in to that, again, 12 o'clock Central Daylight Time next Wednesday. So, okay, we got some questions, Craig, and we'll start off with really important information. How receptive have farmers been to considering, some of these 4R management practices, maybe some of the newer technologies, or what might be some of the barriers to adopting that in your area?
Okay. Yeah, I've been working for a number of years with innovative farmers locally. And a lot of them do, in fact, now use inhibitors. I was talking to a local sales rep talking about inhibitors going off the shelf this year. There's also a federal program in Canada to help subsidize these dual inhibitors as well, which probably helps as well. So yes, they are being used. Not everywhere. It's the more innovative farmers are using them first, seeing how they work, and then the word spreads. The other practices, delaying application, well, then you have to be able to have the equipment, and it's, injection is sort of the way to go. So the limitation is having equipment. And going one step further, it's one thing to go with a single injector, but we've seen even larger benefits. So there is the upfront cost. But if you're consistently getting, 10% yield increases, you can sort of figure out that it would be affordable over a long time period, especially if you're growing a lot of nitrogen demanding crops like corn. Delaying application is something that has worked. Cover crops is another one. There's many ways of doing it. Even I didn't have time to talk about it, but I even looked at different crop rotations and how growing corn after corn has much higher losses than growing corn after wheat or after soybeans, because it's sort of the XSN from the last year's corn sort of builds up. So there's many ways of doing it. What you have to do is choose what will work now, and then when it's time to replace equipment, maybe consider, better injectors or dual injectors and so forth.
So I had not seen some of your cover crop work before, which is really interesting. So question, how prevalent is cover crop use in your area?
Well, cover crops have been used for decades, especially the standard has always been red clover underseeded into wheat. That being said, Cover crops have been used, tomatoes a lot for decades, in particular on the sandy soils, wind erosion, sandblasting. But now crops like cereal rye. I have a colleague who's had a lot of success with using hairy vetch, and some of the clovers. So yes, there's I guess there's a lot of evidence that the more sort of innovative farmers are trying them. And again, it's managing that crop around your system, and even things like, okay, yeah, also have to manage your nitrogen in order to avoid that immobilization, that tie up. So the idea that you could probably put the nitrogen a little bit below where that active decomposition. So it's starting, but it's like everything else, it takes a while to become adopted. But there's many benefits: increasing carbon, reducing soil erosion. If it's a legume cover crop, it'll also supply nitrogen, so you can back off on your fertilizer a little bit as well.
Okay, great. Another one, have you done any work with Y drops?
Yes, but only 1 year. Unfortunately, in last year, and I'm repeating it this year, so we had these wind tunnels with Y drops, and we tried Y drops simulating with a liquid versus solid. And we did a really, really good job at fertilizing the air. We were losing 60, 70% of the end. Because the problem was we were applying it, yes, we were probably at the 10, 11, 12 leaf stage, but it was extremely hot, temperatures above 30, humidex, approaching 35, 40, Celsius, sorry. But it was hot, like over 100 degrees. And so what we're seeing there is that, basically it was just sitting and ripe for loss. The crop canopy can pick up a little bit. I remember Tony Vine from Purdue a number of years ago saying that maybe of the end that's volatilized in a tall canopy, 15% could be picked up by the leaves, but that also means that 85% is actually goes up into the air. So unfortunately, the 1 year that I've tried it, and that's not, I wanted, again, we're going to try late application this year. The problem is the nitrogen is on the surface, it's hot, and it's just ripe for loss. And when I compared the yields of the Y drop application with just, at 10 leaf stage, with the side dress application of injecting UAN, our UAN again had, significantly higher yields. I don't remember the exact value, but it was at least 10% higher if I recall. So unfortunately, I haven't had my experience under our conditions. It didn't work, but that's just 1 year, and that can't really say a lot about 1 year, but that's my limited experience with it.
You said you're continuing that this year, so you may have more information in the future.
That's right, yes.
All right. All right, those are the questions that I have gotten. So, but I'll go through again. If somebody has a question, feel free to type it in. But if you need a CCA CEU, email Elena Whitaker by 5 o'clock today with your name, the name you entered to watch the webinar, and your CCA number. And her email is alenaw@iastate.edu. And then also, please consider tuning in next week for Shane Wolf talking about wetlands. Shane is with the Iowa Department of Agriculture and Land Stewardship. And as always, if you missed a webinar, they are all archived on the Iowa Learning Farms website. So you can go back and watch that. Or if you missed something from Craig's today, it will soon be up there. And it looks like the recording worked. It'll soon be up there, and you can watch it and take a look at it. Oh, okay. There's a question that came in. So my rattling on got one more question asked here. What was the cover crop? Just confirming the cover crop used in the study and when it was terminated. I think you said winter cereal rye, but yeah, when was that terminated?
Yeah, so it was cereal rye that was terminated really a few days before planting. I didn't show it. Again, there's too much data to show, but one of the things that we also had success with was zone till. So we had the cover crop. I was showing you with the cover crop work was all no-till treatments. So we also had a zone till where we cultivated a very narrow zone, probably about 8 inches or so. Yeah, so we cultivated that zone through the cereal rye, had really good emergence and good yields with that as well. So yes, it was sprayed out and then planted into the sprayed cereal rye.
Another one came in is, can you explain the depth of nitrogen placement when you had that rye cover crop?
Yeah, about 3 inches.
Okay.
And again,
7.5 centimeters.
Is to try to put it below the, I'm sorry? 7.5, yeah.
Or 7.5 centimeters. So I'm doing, sorry, I just said,
right.
Yeah. All right. Craig, thank you so much for participating in our, okay. There was a question and I'm not sure, you might not have an answer to this because I'm not sure how much anhydrous you use, but there was a question, what's a good split between anhydrous in the fall and UAN? I'm assuming UAN in the spring.
Yeah, I know there in our area, there's really no anhydrous going in the fall. Out in the prairies, yes, but here, anhydrous going in the fall is going to end up in your tile drains if you have tiles. We have just so much rain that just washes it right through. So we don't see a lot of anhydrous, but no, I haven't directly worked with it. I guess there are some, but it hasn't increased. Backing up a step, 74% of nitrogen fertilizer sales in Canada, I don't think it's that different in the US, are urea and UAN. So I've focused on those two products and, to try to restrict the number of treatments and so forth.
Yeah, that was just kind of a, point for anybody that's interested. That was, as we worked on this regional project, Craig and I, we tried to have a kind of a farmer standard practice and then a 4R enhanced 4R practice. And as we started to talk about the treatments, that farmer standard practice really varies a lot. For us in Northwest Iowa, it was use of anhydrous ammonia. Whereas if you got into Indiana, where Craig's at, there really no anhydrous use. So it was more of, UAN or urea. So pretty kind of interesting what we see in one area as far as the primary nitrogen source really varies. So with that, Craig, I'll give you the last word if you have any last comments. Otherwise, thanks so much for your participation and thanks everybody for tuning in today.
Okay, just sort of concluding, there are multiple ways of achieving it. You can sort of start small even by just adding one practice again, but if you can stack practices, as we saw, they're even more effective and you might be able to save a few fertilizer dollars. There was a question that just came in about the modeling, and we have been doing modeling. We work with modelers. Matt and I, a number of years ago, had both of our data in a model that Ward Smith ran, and I also have we do modeling with this data as well, and DNDC actually models it really well, and we can simulate other practices that we can't have time or resources to look at as well with these models.
There was one, Craig, can you bring up your slide with your contact information? Because there was somebody that wanted your contact information.
Okay. Yeah, by the time, it'd probably be easier for me just to say it. So it's just my name. So it's Craig, C-R-A-I-G. Actually, you know what? I could just put it into the chat.
But in the chat box, okay. I was typing it as you were saying it, but I probably would have messed it up.
It's okay. I'll probably mess it up too. So there we go. Yeah, feel free to give me a shout if.
And that might have just gone to one person. So maybe,
Oh,
yeah, put in everyone there.
yeah. Okay. Yes, that was a direct message then. Let's just. Where is it?
Oh, here. You know what, Craig? I bet you what I can do is.
Okay.
I have it, Craig, here.
Okay. Thanks.
There we go. Craig.Drury at agr.gc.ca.
That's right. Thanks.
Okay. All right. Well, thanks so much, Craig. And again, thanks everybody for attending.